You ever wonder what's under the hood of, say, your operating system, or your web browser, or even the games you play? Well, a lot of them share a common ancestor, this really powerful language called C. So today, we're going to break down its fundamental grammar. And the goal isn't just to memorize rules, but to really learn how to think in C. So let's dive right in.
You know, the best way to tackle a language like C is to think of it just like, well, learning any new human language, right? You don't just jump in and start writing poetry. No, you start with the absolute basics, the alphabet. You learn the letters, then you string them together to make words, and then those words form sentences. And that simple idea, that's going to be our roadmap for this whole thing. Okay, so here's how that whole analogy breaks down. It's pretty straightforward, really. In English, you've got alphabets that make words and words that make sentences. Simple enough. In C, it's almost the same. The character set, that's our alphabet, forms what we call tokens. Just think of tokens as the words of C. And those tokens, they come together to form statements, which are basically our programming sentences. And the whole point, the end goal, a program that actually works.
All right, before we jump into C's alphabet, let's just pause for a second and ask why C? I mean, this language was created way back in 1972. In the tech world, that's practically the Jurassic period. So how on earth is it still such a powerhouse today?
So, C was born at the legendary Bell Labs, created by the one and only Dennis Ritchie. Its original job? To build the entire Unix operating system. That's a huge task. And right away, it got a reputation for being super reliable, surprisingly simple, and just incredibly fast. But its real magic, its superpower, is that it's a middle-level language. What does that mean? Well, it means it's got the raw power of a low-level language to talk directly to computer hardware, but it's still easy to read and write like a high-level one. It's truly the best of both worlds.
Okay, so let's get back to our language analogy and start putting the pieces together. The very first step is learning how to go from individual characters, the alphabet of C, to its words. And in the world of programming, we call those words tokens.
So what in the world is a token? It's really just the smallest little unit in a program that the computer actually understands. Think about it. In English, the word cat has meaning, but the letters C, A, and T by themselves, they're just letters. A token is the whole, meaningful word.
Now, it turns out C has 6 different kinds of these words, or tokens. You can see them here, things like keywords, identifiers, operators. But look, to get a really solid foundation without getting overwhelmed, we're just going to focus on the 3 most important ones to start.
Yep, we're going to zero in on these 3 right here. Keywords, identifiers, and constants. Seriously, if you can get a handle on these, you've basically got the core vocabulary you need to start building your very first C sentences.
First up, keywords. The easiest way to think about these is as the built-in, unchangeable vocabulary of the C language. Words like int, if, or return, they have a very specific, reserved meaning. C knows exactly what they do. There are only 32 of them, and you can't mess with them or use them for your own names. They're kind of like the fixed grammar rules of the language.
Okay, next up we have identifiers. So if keywords are the words C already knows, identifiers are the custom names that we get to create. On the left, you can see some perfectly good examples. First number, user_age. The computer gets these no problem. But on the right, well, that's where we see the rules. You can't have spaces, like in first no. You can't start a name with a number. And you definitely, absolutely cannot use one of those reserved keywords, like int, for your own variable name. The computer will just get confused.
And that brings us to our third key type of token, constants. This one's super simple. Constants are just fixed values, stuff that doesn't change. So you've got integers, which are just plain old whole numbers. You've got real numbers, or floats, for anything with a decimal point. A character is just a single letter inside single quotes. And a string? That's just a bunch of text inside double quotes. That's it.
All right, so we've got the basic words down. We know about keywords, identifiers, and constants. Now, let's start using them to name the nouns of our program. The actual data our code is going to be messing with.
And this is where variables come into play. A variable is nothing more than a name, one of those identifiers we just talked about, that points to a specific spot in the computer's memory. It's literally like putting a label on a box. You can store information in that box. And the really cool part is, you can change what's inside that box whenever you want.
But hold on. Before we can start using that labeled box, we have to do one more thing.
We have to tell the computer what kind of stuff we're going to put inside it, and that's where a data type comes in. It's like telling the computer, hey, do I need a tiny little box just for a single letter, or do I need a much bigger box for a huge number? This is absolutely crucial because it lets the computer know exactly how much memory it needs to set aside for that variable.
So here are the big three, the most common data types you're going to see all the time. The keyword int, that's for integers, whole numbers. Then there's float, which is for any number with a decimal point. And char is for just one single character. And notice, just like we said, each one needs a different amount of memory.
Okay, it's time. Let's put everything we've learned together and build our very first C sentence, or as it's properly called, a statement. Take a look at this line. Int age equals 25. We can actually break this down now. Int is the keyword, telling us the data type. Age is the identifier, the name we came up with. The equal sign is an operator. 25 is our constant value. And that little semicolon at the end, that's super important. It's like the period at the end of a sentence in English. It tells the computer, okay, this thought is complete.
So, we've got our nouns figured out. That's our data, our variables. But a sentence with just nouns is kind of boring, right? To make a program actually do something, we need verbs. And in the C language, our action words, the things that let us work with our data, are called operators. And hey, good news! You already know most of these from grade school math. You've got your plus for addition, minus for subtraction, the asterisk for multiplication, and the slash for division. Now, the one that might look a little new is that percent sign. That's called the modulus operator. Sounds fancy, but it's super simple. It just gives you the remainder left over after a division. That's all. But what happens when you start mixing them up in one line? Let me ask you this. If the computer sees an expression like I equals 2 plus 3 times 4, what do you think it does first, the addition or the multiplication?
Well, the answer comes down to a rule called operator precedence. And this is exactly the same order of operations you were taught back in math class. You might remember it as PEMDAS or BODMAS. The grammar rule in C is simple. Multiplication and division always have a higher priority than addition and subtraction. They get to go first.
And because of that rule, the computer doesn't just read from left to right. Nope. It sees 2 plus 3 times 4, and it immediately does the 3 times 4 part first, which is 12. Then it goes back and does the addition, 2 plus 12, which gives us the final answer of 14. Getting this concept of precedence is absolutely key. Otherwise, your code might give you some very surprising results. Okay, we've come a long way. We have the characters, we have the words, we even have the sentences. But there's one last big piece of the puzzle. How does this C program, which at the end of the day is just a simple text file, how does that become something the computer can actually execute? Let's take a look at that final journey. So here's how it all happens, from your keyboard to a running program. Step 1, you write your source code. That's just the plain English-like C that we've been learning. Then a special program called a compiler comes in. Think of it as a master translator. It takes your code and turns it into object code, which is a language the machine can start to understand. After that, a linker steps in. Its job is to grab any other bits of pre-written code you might need, kind of like puzzle pieces, and link them all together with your code. And then finally, all of that gets bundled up into one single file, the executable. And that's the program you can actually click on and run. And all of this brings us to one last big picture thought. The reason C is still so powerful, even after all these years, is its ability to speak the machine's language directly. It gives programmers this incredibly fine-grained control over the hardware. So, I'll leave you with a question to chew on. In today's world filled with automation and much easier, higher-level languages, what's the value in knowing how to speak the machine's native tongue? It's definitely something to think about. Thanks for watching.